I've been in networking for over a decade and decided to make some content to try to help others understand this industry. Let's talk about how we find the network ID, broadcast address, and usable address range when the transition from network bits to host bits does not land on the octet boundary. These are the possible octet values for the subnet mask. Since the subnet mask is a sequence of ones that then transitions to a sequence of zeros, only one octet can be a value other than 255 or 0. That doesn't mean an octet has to be something other than 255 or 0, just that if there were a number other than 255 or 0, it can only happen in one octet. For more information about this, please review the subnet mask video. Let's take one of these values as an example to dive into. So we're going to use an IP address of 192.168.0.1 and a subnet mask of 255.255.255.240. We're going to go kind of fast here with the ANDing, so please review the AND gate video and the subnetting part 1 video if any of this is unclear. First, let's find the network ID. Since the first 3 octets of the subnet mask are all ones, we know that the result of the ANDing with the first 3 octets of the IP address will result in the same values as what's in the IP address. So for the network ID, we know the first 3 octets are going to be 192.168.0, but we don't know what the last octet is. So to find the last octet of the network ID, let's look at the binary. So the 1 in the last octet of the IP address will be 7 zeros and a 1 in the ones place. That's the binary representation of that octet for the IP address. The 240 in the last octet of the subnet mask, that's going to be 4 ones followed by 4 zeros. So we can see that none of the ones align between the binary of the IP address and the subnet mask. So the resulting of the AND is going to be all zeros. When we convert this to decimal, it's going to give us a decimal value of 0, so the last octet of our network ID will be 0. So far, this is pretty straightforward. Our network ID is 192.168.0.0. So let's go on and look at the broadcast address. And here it's not going to be as simple as the last time we looked at this because not all bits in the last octet are host bits. So we need to identify the host bits based on the subnet mask. And those are the bits where the value is 0. If we write out all 32 bits of the subnet mask, it would look like this. So lots of ones there and then 4 zeros at the end. It's still 32 bits. So we can see that the last 4 bits are the host bits. The network ID is when all host bits are zeros, and the broadcast address is when all the host bits are ones. The first 3 octets are all network bits, so we can just copy those down to the broadcast address because we know when we do that AND operation, it's going to result in the same 3 octets. So our broadcast address, the first 3 octets are going to start with 192.168.0. And now we need to look at that last octet to find that value. So we need to keep track of the network bits and the host bits here. So we only set the host bits to ones to find the broadcast address. The network bits have to stay the same as what they are in the network ID. So here we have the last octet of the network ID. That's all zeros. So we can see that when we align that with the binary for the subnet mask, the last 4 bits here, those are the only ones that we're focused on. The first 4 bits can't change because they align with ones in the subnet mask, which designates them as network bits. The 4 bits at the end of the subnet mask that are zeros, those are our host bits. So when we take those last 4 host bits there, we have to set them to ones in order to find the broadcast address. So when we do that, this gives us a decimal value of 15. So the last octet of the broadcast address is 15. So our broadcast address is going to be 192.168.0.15. So the last thing we need to do is derive the usable addresses for this network. Now, Hopefully this is the easiest part because we just include all host bit values between the network ID and the broadcast address. In this example, the value after the network ID would be 192.168.0.1, and then the value right below the broadcast address is going to be 192.168.0.14. So in this example, we have 4 host bits. 2 to the power of 4 is 16, so there should be 16 values for this network. The first value, where all host bits are zeros, those 4 bits are zeros, that's the network ID. And the last value, where all 4 of those host bits are ones, is the broadcast address. So we've burned up 2 of these values just for those 2 reserved addresses, the network ID and broadcast. We had 16 total, so that means we have 14 values that are left that we can then assign for members of the network. So let's look at another example. Let's keep our subnet mask the same and change the IP address for a little more of a challenge here. By keeping the subnet mask the same, hopefully it's familiar and we can really focus on what's happening in the binary. So the network ID, it's going to be the same for the first 3 octets as what's in the IP address. We saw that before, since those first 3 octets are designated as network bits because there are ones in the subnet mask for those bits. So our network ID is going to start with 172.16.27. So we'll follow the same process as before by doing the AND operation on the bits in that last octet. So here we have the last octet of the IP address in binary, as well as the last octet of the subnet mask. When we AND them together, we get a result that's a decimal value of 96. So this means our network ID, it's going to be 172.16.27.96. So the next thing we need to do is find the broadcast address. Once again, the first 3 octets of the broadcast address are the same as the network ID because those are all network bits, and they will not change any values when we set all those host bits to ones. So our broadcast address is going to start with 172.16.27, and then we need to focus on that 4th octet. The first 4 bits of the last octet, they're network bits. So again, that's designated by the subnet mask. The fact that there's a 1 for those bits in the subnet mask means it's a network bit. And so those don't change. Right now with our network ID, we have 2 bits there that are ones. They're the second and third bit that from left to right. The second and third bit are ones. They have to stay ones because those are network bits. We're only putting the host bits to be ones, and that's how we find the broadcast address. So the last 4 bits are the host bits. Again, that is based on the subnet mask. A 0 in the subnet mask means that that's a host bit. So we need to set all those to ones. And when we do that, when we set those last 4 bits to a 1, we convert the entire octet to decimal and not just the host bits. So this is where some people get tripped up a little bit. So don't forget to include all 8 bits when doing the conversion to decimal. So this gives us a decimal value of 111. So the broadcast address is 172.16.27.111. The usable addresses are going to be the values between the network ID and broadcast address. So this would give us 172.16.27.96 all the way through 172.16.27.110. So since there are 4 host bits in the subnet mask, we still only have 16 values. 2 of those values are used for the network ID and the broadcast address, so we have 14 usable addresses for members of the network. So let's look at one more example, and if this one makes sense, then we should be able to find the network ID, broadcast address, and usable range for any network. So we're going to keep our IP address the same, and it's going to be 172.16.27.103. But this time we're going to change the subnet mask so that transition from network bits to host bits, it's not going to happen in the last octet. Now it's going to happen in the 3rd octet. So our subnet mask is going to be 255.255.240.0. So now let's find the network ID by using the same process we did before. So this time the transition from network bits to host bits, it happens in that third octet. That means only the first two octets of the IP address are going to be the same for the network ID. We can also see that the last octet of the subnet mask is all host bits. And remember, for the network ID, all host bits are 0. So that means that last octet is going to be all zeros, which means the decimal value is 0. So we can put a 0 there for the last octet of our network ID. So the place that we really need to focus now is in that third octet, because that's where we transition from network bits to host bits. So we need to convert the third octet of the IP address and the third octet of the subnet mask to binary in order to do that AND operation. So this is what that binary looks like. And when we do that binary ANDing, we get a result of a decimal value of 16. So that means our third octet of the network ID is going to be 16. So our network ID is 172.16.16.0. So now we need to find the broadcast address. Remember, the broadcast address is when all host bits are 1s. So since the first two octets are all network bits, again as designated by the 1s in the subnet mask, we can make the first two octets of the broadcast address the same as the network ID. So our broadcast is going to start with 172.16.something.something. So now we need to set all the host bits to 1. So the first 4 bits of the third octet are network bits, and so those cannot change. So those first 4 bits are 0001. And then those last 4 bits, those are host bits. So when we set the host bits of the third octet to 1s, we get a decimal value of 31. Because remember, we have to add in any of the network bits that are part of this octet. Those have to be converted to decimal as well. So 31 is the value of the third octet in the broadcast address. Now we still need to put a value in for the fourth octet. When we look at the subnet mask, we see that that fourth octet is a 0, which means all of those bits are host bits. So in our fourth octet of the broadcast, if we were to turn all those bits to 1s, that's going to be 255. So we know that our last octet is going to be 255 for the broadcast, giving us a 172.16.31.255 as a broadcast address for this network. So the next step in finding the usable addresses, this piece of it kind of messed me up when I first started learning networking because I wasn't accounting for all of the bits in the binary. I was looking just at the decimal, and it masked some of the things that were going on behind the scenes here. So let's look at the binary of the second and third octets of the network ID. I'm sorry, these are the third and fourth octets of the network ID. In this case, the first 4 bits of that third octet, they're the network bits. So those cannot change. Those have to say 0001. There are a total of 12 host bits for this network. So it's the last 4 bits of the third octet and all 8 bits of the fourth octet. So that gives us 12 total. So to find the next value higher than the network ID, we increment that very last bit. So when we do that, this would make our first usable address 172.16.16.1 because we increment that fourth octet, not the third octet. So we need to keep this in mind when finding the value right below the broadcast address, which would give us our highest IP in our usable range. So here's the binary representation of the third and fourth octets of the broadcast address. Again, those first 4 bits in the third octet are network bits, so those don't change. But the last 4 bits of the third octet are all 1s, and then all bits in the fourth octet are 1s. That gives us our 255. So when we decrement down 1 value from here, it has to be done in that fourth octet. So this means that that last bit in the fourth octet, it goes to a 0. When we convert this to decimal, this makes our third octet still a value of 31, but our fourth octet is a value of 254. So the highest usable address we have is 172.16.31.254. So there are 12 host bits for this network, and 2 to the power of 12 is 4096. That means this network has 4096 values. We still need 2 values for the network ID and broadcast address, but that still leaves 4094 values to be assigned to members of the network. When we had 4 host bits, there were 16 values, and with 12 host bits, we have 4096 values. So changing the subnet mask value to adjust how many usable values there are is what subnetting is all about, and that's what we'll look at next.